So we're here to talk about merging and rebasing. As I said, this is based on an entire blog series called Git Panic that started the second time I cried about interactive rebasing. And to that point, please do not get panicked during this presentation. This covers 5 articles of an 11-article series. I'm going to glaze over even more information, and all of that information is available to you. Here's a link to the series. Here's a QR code to the slides. Here are the repositories I'll be using for examples. I'll give you the QR code and more resources at the end. So do not get panicked. Do not feel like you have to memorize this all or write it down. It'll be here for you. Let's get on the same page. Git is distributed version control, which you know what version control is. If you know that 2.0 is better / newer than 1.0, distributed means that Git, just like a database, is concerned with anybody being able to make any changes at the same time as somebody else and not overwriting anybody's work. You're storing something in Git, it's in a repository. The local is sometimes referred to as the downstream. It's the one that's on your machine. It's the one that if someone else wants to see it, they have to physically walk over to your computer. The remote is often called the origin, sometimes called the upstream, and it is the one that's in the cloud and somebody else's servers. Everybody can view it on GitHub. You're not the only one that can see it. We're going to be using Git Kraken, a GUI. I will be saying GUI because I can't say GUI without giggling. And in Git Kraken right now, you can see that all of my branches have a little GitHub icon to indicate that they are remote, and a little computer icon to indicate that they are also on my local. And Git is mainly concerned with changes. It's going to look at your new changes, compare them to the old changes, and spit out a snapshot called a diff or difference. So here's a split diff. We've got the removed changes, the deleted ones in red on the left in their own file. We've got the added ones in green in their own file on the right. And you can see in whatever UI I pulled this from in GitHub, there is a pretty obvious split versus unified button. And unified has all of the changes in the same file. I personally find this one easier to read, especially when you start moving large chunks of code around. You have your deleted red code above your added green code in one file. And obviously this UI has a pretty obvious button, but pro tip, if you don't see the button, go to settings. There's pretty much always a way to switch to the one that you find easier to read. One of the ways that we make Git's life easier is by making branches. Also, merging and rebasing helps Git reconcile changes. So we're really helping Git do Git when we do these things. If I want to see all of my branches in my current repo, you just run the git branch command, and you'll see in my terminal, there's a color change and an asterisk to indicate the branch that I am in the context of. If I want to create a branch like, I don't know, new branch, the branch names don't get any more clever throughout this talk. Then it's created, but you can see from my terminal script that still says main. And if I run git branch again, the asterisk and color change are still by main. So I haven't checked it out or moved into the context of it. So if we git check out new branch, then my terminal script will print out new branch, and you'll see git branch also has the color change in the asterisk next to new branch. In that 11-article series, there is how to make this terminal script if you also, like me, forget which branch you're in often and need the computer to remind you. But Git knows we probably don't want to do that every time we want to make and check out a branch. So we have the B flag for branch, and newer branch will be created, and I will check it out with that flag. Beautiful. So now that I have a branch, I probably want to start making changes. Oop, that is not what I was trying to do. I'm trying to go to this one. So in my branch, I'm going to start making changes. And when I do that, if they are tracked, so Git is paying attention to them, they're not in your .gitignore file, they're going to start out in the working directory. If they are, let's say I want to change this to the Pokemon page because I think it will help my SEO, and I save, I expect Git Kraken to show a dashed line because I haven't commit this. There is no committer, so it can't give a little default guide for me because I haven't paid for Git Kraken. But it does still have some information if I click on it and some other things I can do. Before we get to staging it, I do want to mention that if you run the git stash command, this will remove the changes from your current context, so out of the branch that you're in, but it will not make them go away. It will basically put them in a bucket that will be next to the tree that is Git, and you will be able to access these changes from anywhere, any branch, anytime. You can, if we go back to Git Kraken, now these changes are in a little dash square with a little inbox icon because they're saved, they're there for you. And this is a great thing for when you need to, I don't know, review a coworker's PR and pull down their branch, but you aren't done with your work, or you forget which branch you're in. You need to go to the other branch. And to demonstrate that everything I'm doing in command line, you can do in a GUI like Git Kraken, or probably in a UI like GitHub. And I'm not saying you have to learn how to do all this stuff in command line. I'm just giving you the mental models to know what buttons you're reaching for. So I'm going to go ahead and apply that stash so it'll go back to my working directory. And then I'm going to delete it because we don't need it cluttering up what we're about to be doing. We've already got enough branches here. So now I like these changes. I want to stage them. I'm going to stage them by running git add dot. And that's going to stage all of the changes in my working directory, which means that there is an option that you can pass to git add that is not all, right? I think VS Code source control shows us a little bit better than Git Kraken, but I can individually by file stage and unstage changes with buttons here. It's back in my working directory. Now it's in my staging area. If I had multiple files, I could choose to do just some of those files. And there are also other ways that Git allows you to stage changes that aren't by file name. So basically, the staging area is just a place where you go, hey, Git, if I am going to commit, these are the changes that I want in that commit, not all of them, just those. So I'm going to go ahead and commit. And when I do this, I expect the Git will open an edit window, right? And this may be the bane of your existence if you try to avoid doing Git in command line. My recommendation is that you associate a text editor with Git, which we will get to in a second. But what just opened is a VI window. It uses Vim commands. I'm not saying you can't learn Vim commands. I'm not saying you can't learn interactive rebase. We will in this talk. I'm saying if you try to do both at once, that's a learning curve that is way harder than it needs to be. And I know because I've cried about it twice. So associate a text editor with Git. Use a UI or a GUI. World's your oyster. There are lots of tools that will help you in Git. Git has a whole page in their documentation dedicated just how many GUIs are out there. So I'm going to go back in here. I'm going to hit I to enter insert mode. I'm going to delete the parts of my commit message template that I've made. That's also in the blog series. And use the least descriptive commit message ever because it's not what this talk is about. That's another talk. I'm going to hit escape to exit insert mode. I'm going to hit :WQ to tell the VI window to write and then quit. And then I will have in Git Kraken a solid line around my commit. We've succeeded. It is there. But what's in that commit? Well, we've got a reference to the commit itself. We've got a reference to the parent. We've got my name. We've got information about the file or files I've edited. And there's our diff again. We know Git loves diffs. If I had authored code, but I didn't commit it, my name would still be in there. You still get credit for that. We had our commit message in there, and we had plenty of refs, which I pointed out. And if we didn't want to use a GUI, we can use the git log command, as we can see from our Seagull Galaxy Brain friend here. Git log is so configurable. I'm pretty sure if we tried hard enough, we could make the Git Kraken tree that Git Kraken has just with git log. I haven't tried. We can see if someone wants to try that. But it'll print out your entire commit history. It'll have the latest commits at the top. So if I run that now, we'll see the same commits we were seeing in Git Kraken. It'll also tell us which branches they're in, and we can hit Q to quit if we don't want to see the whole thing. I have been talking a bunch about refs, but what are refs? Refs are a human readable reference to a thing. Everything in Git has a ref. A branch name is a ref. Origin is a ref to the remote repository. You can create tags for even more version control and even more refs. All of them are stored in .git/refs, which is a pretty cool folder. If that interests you at all, go ahead and check it out. And git ref log will show you all of your refs, just like git log. It's highly configurable. It'll have a ton of information, queue to quit. And why am I hyping on refs so much? It is because recovering lost work in Git is almost always possible for months. The ref garbage collector does not run for several months. So as long as you can find a ref to the work, you can restore that work. There's a whole blog on it. But when we get to the scary stuff, remember, I can always find a ref. Commits themselves have multiple refs. The one that I was pointing out, I'm going to call a SHA. You can call it a reference ref or hash. It's a unique identifier for a commit made using the SHA-1 hash algorithm. You'll see anywhere from 5 to 12 characters in the wild. 8 to 10 characters is recommended by the Git reference documentation because Git is pretty smart about matching SHAs. However, the Linux kernel did find that when they hit about 875,000 commits, they did need 12 characters to accurately match SHAs. So keep that in mind if you get to that many commits in your repo. Commits themselves have multiple refs. So we're also going to talk about head. Head all caps refers to the branch and the last commit on the branch. Head lowercase just refers to the last common commit, or the last commit. It's not as commonly used. Head up caret, which is the same as head up caret 1, refers to the parent commit of head, and you can enter a detached head state. And at this point, many people may be like, Abby, I know how to commit. I know how to make a branch. Why are we talking about this? That's because I want you to visualize commits in branches. Commits are not just the commit themselves. They are also the relationship to every commit that came before them, so much so that we have a shorthand for it. Head up caret is the parent commit of head. Head up caret 2 is the parent commit of the parent commit of head. Head up caret 3 is the parent commit of the parent commit of the parent commit of head, all the way back until you get to that commit where you ran your git branch or git checkout command to create that branch. And that commit that you were checked out at when you ran that command is the last common commit between those two branches or the parent commit of the new branch. So what about detaching our head? If I look at newer branch, we currently have one commit on here. That's going to be head. And you'll see that Gitkraken is not telling us where head is. But if I run git checkout head up caret, I am now going to be in a experimental state. My head is detached. That last head is out there in the ether. It is not forming relationships with any new changes that I make, and Git is telling me that it does not like that. It needs the relationships. It needs the drama. And you're not going to create that if you make new changes. They'll all be experimental. What is it going to do with that old commit? It does not know. And you'll see that right now, Gitkraken is telling us where our head is at. If since we know that all I need is a ref, we can go ahead and copy the ref of the commit at the end of the branch and go ahead and check out that. And Git won't tell us that we're in an experimental state with a detached head, but Gitkraken still feels the need to tell us that where our head is at. And that's because we're in the context of one commit. We're not in the context of the branch. So we can go ahead and git check out newer branch to get back there. All right. So now we'll talk about fetching, which is not merging and not rebasing. All it will do is download your refs and information that you need from the remote repository. Based on my experimentation and attempts to read the documentation, by default, I think git fetch is git fetch remote all branches. And here is a command to configure git fetch to delete all of your branches for you if they're unused in the remote. It will not reconcile changes. We have to use merging and rebasing for that, which means if you totally mess up merging or rebasing, if you just absolutely destroy your local branch, you just delete it. You just get it out of there. And then you fetch and you get a brand new clean copy of the branch from the remote. So we can use this when we're doing the scary stuff to always have a fallback. We can mess it up as much as we want in local because we will always have that clean copy in remote. So I made new branch a while ago. I don't really need it anymore. I want to delete it. And since it doesn't have any commits in it, git branch lowercase d will totally let me delete it. It'll be like, get it out here. But if I go back to main and then try to delete my newer branch with that one commit in there using the lowercase d, Git will be like, I'm sorry, you can delete work. You're going to delete work. Please don't do that. So if you're deleting branches, go ahead and default to lowercase d, but if you know you don't want that local work, you can use uppercase D and it'll work totally fine. So now let's talk about merging and rebasing, which is reconciling changes. This is when you need to get new changes that your coworker pushed the remote incorporated into your local, when you need to put your new changes up into the remote so your coworkers can use them, or anytime you just need to smush two branches together. At a very, very technical level, merging is Git saying, now kiss, and then taking notes on how the changes kiss, and then slapping those notes on the end of the commit history. We're going to go ahead and start with the merge commands. The base is always head, so wherever you're checked out to, that is where the merge changes will be put. And you can merge as many branches into head as you want. You can keep passing branches the merge command, and it'll be like, great, let's go. But the base is always head. The simplest possible merge is a fast forward merge. It technically uses rebase under the hood, which will make sense later. So there's no merge commit. We don't need to slap notes on the end of the commit history. And Git always tries to do this first. This is what happens when you make a branch and you're making changes, and by the time you're ready to incorporate those changes back into main, your coworkers haven't had a chance to push any changes at all. It's just you got some commits, they're right after the last common commit or the parent commit of that branch. It's all good. We just go ahead and slap those commits onto the commit history. So Git is going to look at the last common commit. It's going to check if all those commits come right after it, and if they do, it's just going to update the commit history for you. So per my incredibly clever branch naming scheme, we have fast forward merge as branch name. It has two commits on it, and they come directly after the last commit on main. So if we run git merge fast forward merge, I expect to see those two commits right on top of main, and Git prints out fast forward. So you know that it was able to do that without any merge commit. And now Git Kraken is showing my local main is right on the tip of fast forward merge. They're both up here and based off of where main is in the remote. Pushing will only fast forward merge. If you can't fast forward merge, you're going to have to do a more complicated merge. Git will just go, oh, there were some refs rejected, and not do it. So git push by default is git push remote current branch, and we have a branch that has some new information on it. Git checkout newer branch, and we want this commit, which is currently only in local, to end up in our remote. So we're just going to run git push. But there are no refs between the remote and the local, so we also have to set up our refs. So we're going to run git push set upstream origin newer branch, and now Git is telling you you can open a pull request if you want. I updated these refs for you. Oh, because I didn't show you fetch. Let's go do that. So if we create a new branch called fetch me, and we now know that it's up there in the remote, and I need it badly. It needs to be fetched. We're going to run git fetch, and just like we saw with pull, it's going to update those refs so that now those two branches are linked. And if you can't do a fast forward merge, what do? You do a three-way merge. It will not happen with push. You will have to actually trigger a merge another way, but the name comes from the three commits that Git is comparing. The last common commit or the parent commit of new branch, the last commit on the base branch, because it has all of the information about the commits that came before it. So it's just all of those changes Git is looking at. And the last commit on new branch. So all of the changes on new branch. This happens in a situation where you've made a branch, you've been working on your feature, and by the time you're ready to reconcile those changes, your coworkers have managed to push their work into main. So you're going to have to reconcile that. Git's going to look at the changes in main. It's going to look at the changes in new branch. It's going to take notes on how they kiss, and then it's going to slap those notes on the end of the commit history. So, shockingly, we have a branch called three-way merge. And even before we put those fast-forward branch commits onto main, these two commits came from an older commit. Main was, where's that bad boy? It was here. So, already we would have had to reconcile these changes, but now our coworkers have added 2 fast forward merge commits. So we're also going to have to reconcile those. So I don't think it is going to, well, let's check out main. And then we're going to merge, 3-way merge into main. And I don't think it's going to print out fast forward. Instead, it's going to say, hey, do you want to add to my notes about how they kiss? And you're going to go, no, it's fine. Write your message. And when we go to get cracking, it's not going to have my default little Galaga guy on it. It's going to be a closed circle because Git wrote this all on its own. But remember, I said, if you author the code, you still get credit. So I am still on there, even though Git wrote all of those notes. And I think it's pointing the wrong commit. So I authored it, Git committed it, but it's also got 2 commits for the parents. So it's keeping track of the fact that we aren't just fast forward merging and slapping the commits on there. We are actually taking 2 branches and mooshing them together. So now we can talk about pulling. Git pull is the same thing as git pull remote current branch. It's also the same thing as running git fetch and git merge by default. We'll talk about default later. A lot of people run git pull origin main to merge main into their current branch, and that's great. You get your refs, you get your merging, but if Git tells you that your branch is up to date, don't believe it. Go ahead and keep pulling. So let's see. Let's go check out newer branch. And then let's go ahead and git pull origin. What's a good one? Let's do some cherry pick. So my cherry pick branch has a bunch of things in it. It's going to reconcile 1, 2, 5 commits based off of way back in main, and generate some conflicts, which we can talk about now. So perfect. We're going to download all that new information from the remote repository. We're going to try a fast forward merge. If Git can't get a fast forward merge to work, it's going to try a 3-way merge. And if that doesn't work, it's going to generate conflicts. What are conflicts? Conflicts are situations where Git doesn't know what to do. Like 2 people have edited the same line, and it's like, which one is better? I don't know. I need help writing my fan fiction. I must reach for my co-author. Congratulations, you are now the co-author of Git's fan fiction. Each of these situations is called a conflict, and we're going to resolve them by deleting the changes we don't want. You can also add changes, but I don't know if that's great. You got to delete all the markers, so all the lines with the carets and the equal signs, and you got to save the file, run git add dot, and then run git merge continue. And the continue and abort flags work with so many Git commands. This is a great time to talk about if it's going fine, use the continue flag, keep going. If you are Git panicking, use the abort flag, escape, start over. You can always get out of what you've done, especially because we have refs and you can always download a clean copy of the branch. So when I was talking about associating a text editor with Git, I'm definitely thinking about VS Code. It has a nice little interface. We can accept the current change, which is head the branch that we're currently in. We can accept the incoming change, which is coming from the branch that we're trying to merge in, and we can accept both changes, which happens more often than you would think. VS Code also has a little button called compare changes. It opens a 3-window view that overwhelms me, so I don't use it. But all we have to do is press one of those buttons or remove this line, remove the changes we don't want, and then remove our other marker line, save the file, git add dot, git merge continue, and apparently it didn't want to do that. Cool. So now our head is here. We have our home page. I don't know what happened. Let's try that again. Let's check out main. And I don't want to push it. And we're going to merge in 3-way merge, git merge, 3-way merge. Already up to date. All right. So apparently, even though I ended up checked out at head, we can show that if you mess up, it's fine. There's a way to get out of it. We can get back into main. And Git has created a commit message for us. Once again, I'm the author, but it's the committer, and we have 2 parents, but we had to create a merge commit. We didn't get to just fast forward merge. All right. Squashing is a compromise between merging and rebasing. It is for the team who cares about their commit history without the desire to rebase. And you may have used the GitHub UI button. It'll take the entire branch of commits that you have and squash them down into one commit message. It will then allow you to edit the commit message. So instead of everybody having to follow you on your journey to the solution, now you get to describe your entire solution like you never even went on that journey. It's much easier for your coworkers to read, and you don't have to rebase to make it happen. So let's try again, git merge, but with squash, and the branch will be squash. So I expect that my 2 squash branch commits here will end up on the end of main in one commit with the new commit message. And I'm going to combine the 2. So it'll be remove fonts and add title. So we are going to try that. And this is one of the ones that VS Code source control likes to take over for some reason. And it's giving me a very detailed message that is very involving of the commit, and then giving me an error that I should not be getting. So hopefully I will be able to add title, continue. Yeah, ignore VS Code. So hitting the continue button was the same as git add dot and saving the file and then running git merge continue. And if we go back, we now have a commit that was authored by me in newer branch and main. Interesting. Anyway, we will move on to, git merge squash. Git merge squash, yeah, whatever. So cherry picking, not merging, not rebasing, not squashing, cherry picking. Great example for how to cherry pick is I am working on a feature. I have fixed a bug in that feature. The client has complained that that bug is happening. We need to fix it quickly. I just want to pull the commit with the bug fix out of my feature branch and then slap it into main so we can go ahead and get it deployed. When I do this, it's going to be the same thing as copying and pasting a commit from one branch to the other, but it's going to get a new SHA and it's going to get new relationships to the commit before it. So when Git sees this, it's going to be like, these are strangers, not twins. I have to write all new notes on how they kiss. So you can run into merge conflicts doing this, but it's very easy to move commits around and slap them onto whatever you have checked out. So it is a great tool. So we're going to pull, let's say, add link attributes from cherry pick. We're going to make sure we're in main, git checkout main. And, not what I wanted to do. We are going to pull this add link attributes, and I expect it to be on the top of main when we are done. And I'm going to git cherry pick and add my guy, and that's going to cause a conflict. So I'm going to go ahead and accept current change, save. And then do git add dot, git merge continue, and we apparently didn't have a merge in progress. I don't know. At this point, I am tempted to go ahead and restart my terminal because some silly stuff is going down in VS Code. Let's go ahead and try that. And we're going to open git panic. And we're going to pull it from my other screen. And we are in main. Let's see if we can run that squash command again. There we go. We got newer branch and main are up here. We're on update title. We were at squash. So let's try and get these two guys in here by running git merge squash branch. Oh, I have to, of course, I have to conclude my cherry pick. So let's go ahead and get cherry pick, continue. Let's see if that works. Because of the merge conflict. Okay, so let's add link attributes. Let's copy this. Let's get cherry pick. This guy. Beautiful. All right. You know what? Let's always turn it off and then back on again when we don't know what's going on. And so now we have cherry picked right here. And let's see if we can get that squash to work. Let's go ahead and get merge, squash branch. Okay. VS Code takes over. We don't want update title. We want remove fonts, add title. Yeah. Or it's just saying we have a bunch of things to commit. I don't know. I don't want to pull it, so, or push it, because that would mess up my branch. So let's just go ahead and get merge, continue. Nope, no merge in progress. All right, cool. Guess we're not squashing it today, guys. Sorry. Here we go. We're going to move on to finally rebasing. So unlike merging and cherry picking, you get to pick the base. Like merging and cherry picking, you get to pick anything to add into your commit history. You can reference what you would like to add in using head, SHA, branch names, any ref you can think of. It's like a manual fast forward merge. You're telling Git the relationships now, and then Git's going to run off and write its fan fiction based on those new relationships. Git is going to give you the consequences of that, which is usually conflicts. Let's see. The rebase commands. The first option you're going to give it is the base. If you give it a second option, that's going to be what you want to put onto the base. You can do this from anywhere, so you can rebase two branches together from a third branch, but you will end up checked out at the branch that you were trying to rebase on top of the other one. If you don't pass that second option, Git is going to assume that you want to rebase head onto whatever the base is. If so, whatever you have checked out will then be rebased onto that base. You can set pull to rebase. This is what I was talking about earlier, where you merge by default. So here's the command to configure it to rebase. And this only works with you matching the environment you're in. So if everybody's merging and you use the default pull merge, great. If everyone is rebasing and you use the default pull merge, then you're going to end up accidentally triggering merge commits that you're then going to have to rebase out. It's a lot of work for you. And if you're in a merge environment and you've got it set to rebase, you're going to end up rebasing a bunch of merge commits, and it's just going to be a lot of work for you. So match the environment that you are in. So now we're going to run some rebase commands. And what I want to do is take a branch that I was working in that I have based off of a older commit and then move it on to the latest commit. This is maybe like, you're about to open a PR. You don't want to deal with reconciling those changes after you've gone through the review and responded to feedback and changed everything. You want to make sure it's as up to date as possible. And to do that, we're going to use our rebase one branch with super clever titles. And we're going to take it all the way from this commit all the way back here. And we're going to add it on top of add link attributes on main. So we're going to run git rebase main. Rebase one is our branch name, and we should end up checked out in rebase one. We are. And we go back to get cracking. Both of these rebase one commits are on top of the last commit on main, and they're still in rebase. So this would be a great, fresh, up-to-date PR that we could open. A more contrived example is I've been working on a feature for a while. There's a feature branch for another feature. We decided that my feature is part of that feature. But when they were working on their feature, they introduced a breaking change that I don't want to deal with. So I'm going to put my feature into their feature branch, but one commit back, not on head, so that I don't have to deal with their breaking changes until they have added a fix. So what I'm going to do is take a new branch and then put it on whatever commit I find. And we're going to make that happen. So let's start with looking at what we got. Let's say I want to slap it on top of add link attributes. So I'm going to copy that SHA again. And then I am going to take my rebase 2 branch, which is all the way up here, has these two. And when I run get rebase, the SHA I've copied, and then rebase 2, the name of our branch, I expect that these two commits will still be in my rebase 2 branch, but they will be based off of this commit back here. Let's go ahead and run that. Got the SHA, we got rebase 2, and we go back. Beautiful. We have our local rebase 2. It's these two commits, and as you can see, the line is pointing directly to add link attributes. And that's all fine and good, but let's say I want to do some real crazy stuff. First, I have to know that I am force pushing, because even if I'm just telling Git the new relationships between commits, it's going to go up, go to push those commits up, look at the remote history and be like, no, it's not. You're lying to me. That is not the commit history that I see. And you have to go, no, it is. I'm going to force you to see that. And I highly recommend defaulting and running force with lease, because it will try to stop the push if there's work in the remote branch that is not in the local branch when you start the push. Now we can talk about interactive rebase after more warnings, because interactive rebase, you are actually writing the commit history. You're the fan fiction author now. You can do anything. Deleting commits is a feature. More changes probably means more conflicts, and more conflicts make it really easy to overwrite work. Take it from me, if you have to resolve a conflict on every commit that you're rebasing, and there are a lot of rebasing or a lot of commits in there, it gets to that point where like you're writing a word over and over again and it no longer looks like a word. It's bad. So very easy to overwrite work. Commit history can be super important, so you shouldn't just rewrite commit history willy-nilly. We've seen recently with the free open source software security issue that the commit history is part of the way that they found it. There are repos that exist explicitly to have commit history as a public record. So it is my recommendation that you only ever rebase your local commit history or draft PR commits. And I say draft PR because in GitHub, at least, if you start rebasing after somebody else has looked at your PR, that feature where you get to say, I've already looked at this file and only show me new changes goes away. And I have definitely seen comments like disappear because you are lying to Git about what the commit history it is. It has to recalculate everything, all of its fan fiction. So if we start the interactive rebase, first thing you're going to do is push up any changes you want to keep in case you mess up. Then you're going to run git log or use a GUI to find the ref that you need. Then you're going to pass the ref or refs to the rebase command with the interactive flag, so -i. If you want to rebase a branch on top of another, you still pass the base and the commits that you want to move on to it. But if you want to interactive rebase all the commits in your current branch or a branch and just edit the commits, you grab the SHA of the parent commit that you want to edit, because whatever SHA you feed it is not going to print out. It's going to print out all of the commits after that. Oldest commits will be at the top, which is the opposite of git log, ref log, and like every GUI, just to make things slightly more difficult. You can reorder commits. All you have to do is move the line of the commit that is printed out. Every commit is going to start with a keyword next to it. Every commit needs to end with a keyword next to it. The keywords can either be one letter or the long form. Pick means keep it the way it is, use it. Reword means use commit, but stop and edit the commit message. Edit means use the commit, but stop for amending. If you run git commit amend, it will allow you to add stage changes to the commit that you just did. And it will allow you to edit the commit message, which is great if you remember that you needed something in that commit right after you commit it. But if you need to edit like 3 commits back, then you need to use interactive rebasing. Squash is just like squash merge, so we'll actually see it work now. And this time you get to pick the commits. It doesn't have to be everything in the branch. Fix up is like squash, but you don't even want to edit commit messages. Just move the changes into the one commit before it. Exec allows you to run a command. I have asked people what they think running this command here would do. Somebody suggested cherry pick, which maybe. I have personally never used it. If you have a cool way to use it, please do share. And then D is drop. It's delete. Get it out of here. We're not using it anymore. After you tell the VI window to write and quit, you're going to have to resolve any conflicts. At that point, git rebase continue or git rebase abort if you get panicking. Then you have to deal with your commit message editing, and then you're going to run git log or look at the GUI again, because you need to make sure that you like the commit history before you overwrite your clean copy of it. Then you run git push force release. So let's start with some examples. I'm going to switch to a rebase that is easier to follow. We only have 2 branches in here, which means that I need to also open it in VS Code and close my other VS Code window. And now that we're here and we're in main, I can go ahead and run git rebase I main new branch, which is going to put new branch on the latest commit on main. So these 3 commits will move up here, and I will get to mess around with all of the commits in new branch. So here they are printed out. They've all got pick. And I'm going to hit I to enter insert mode, and then I'm going to not use vim commands and just copy the line that I want to move around. And remember, oldest commits at the top. So if I want this guy to be the latest commit, I have to come down here and paste him, escape, :WQ. And now we should have update button name as the latest commit and all 3 commits on top of main. Great. So now let's delete a commit. Back here, I have like enable background colors and then revert background colors. So I probably don't need enable background colors, but to edit that guy, I'm going to need the SHA of his parent. And I'm going to need to check out main so that I'm in the right branch. And then I'm going to run git rebase I and the SHA, and beautiful. Now I don't want enable background colors, so I'm going to hit I for insert. We can use the shorthand this time just to be fun. We're going to hit escape, :WQ. And now it's like I never even enabled background colors. What are we talking about with revert background colors? And we're going to change an old commit message because I put shadowns instead of shadows, and that's embarrassing. And I don't want my coworkers to see that once I push it up. So we're going to pull the parent SHA once again, run git rebase I, and same deal, I for insert. We're just going to delete that in like it never happened. I'm going to hit escape. I'm going to hit :WQ. And now, when we update maybe, did I not? What happened? Where'd it go? No. You're kidding me. Oh, because I just... You can't do that. You gotta hit I and then use the reword keyword. What am I doing? Escape, :WQ. And now we're in the edit window for the message. You can't just edit a message like that. So now we hit I, delete, escape, :WQ, and my mistake is rectified. However, I have also misspelled perimeter. One of these typos was on purpose. And I just hate seeing that. So, I think I want to squash these 2 commits. There was a lot of changes. We ended up with box shadows. So I just want to say box shadows, and I don't want anyone to see perimeter. So we're going to, again, get the parent SHA. We're going to run git rebase I and a SHA. And now we didn't go back far enough because I forgot that they are just in the wrong order, because why would we do it in the opposite order of the thing? So we have now rebased so that only that commit exists, showing you exactly why we keep a fresh copy in the remote. So we're going to go ahead and check out a different branch. We're going to check out new branch. We're going to get branch absolutely capital D main. We're going to get fetch. We're going to get check out main. And oh my gosh, it's like it never happened. We're all back here having a great time. So once again, we are going to get the parent of something that we want to squash. Wow, my squashing is really cursed this run through of this talk. And we're going to get rebase I, that. And then let's see. So we know that oldest is at the top, and we need a commit from the bottom to squash up into the commit before it. So let's go ahead and squash this bad boy. Escape to colon WQ. And now we get the same kind of commit message we saw before. We are going to say, I do not want the perimeter. We're just going to say enable background colors, or no, revert background colors, because that was the latest commit. It really messes me up that these are swapped orders. We're going to say revert background colors. We're going to hit escape. We're going to hit colon WQ. And now, as we can see in revert background colors is all the changes of the two previous commits. We have a new commit message. We finally successfully squashed something. Beautiful. And I believe that was my last example. It is. So here are the resources. Learn Git branching. I have heard devs of all levels love just for helping them visualize branches. Get it. This is your first introduction to some of these basic commands, go ahead and use that. It'll walk you through it, and you'll get a certificate if you finish everything on GitHub. Git reference documentation, a classic. Atlassian tutorials I like because they try to do visualizations in plain English and give lots of examples. Oh shit, Git is a great resource by Julia Evans. Dang it, Git is her clean version, if you didn't like that I just swore. And she has zines by the same name. Here's the QR code for the slides once again. And looks like we have like 5 minutes for questions.
That was awesome. God, it's just, first of all, technical issues have been plaguing us, right?
Right? Yeah.
Yeah. So for what it's worth, Proudcast started working. Right?
Perfect.
Yeah.
Right. You just
so
restart.
We do.
Everything's fine.
Yeah. I didn't do anything. It just started working. Okay. So we do have time for a couple of questions. I did have one already from somebody actually in Crowdcast, so I'm going to ask that one. But if you're watching right now and you have other questions, please just put them in the chat and I will ask them. So Richard asks, one thing I encountered that bugs me is that newer PRs contain older commits from previously squashed merged PRs when creating PR from staging to main. Any idea what causes that? Does that mean? Were you able to follow that? It says.
Yeah.
Yeah.
So it sounds like you're pushing changes up and they are containing references to individual commits that somebody else had squashed, which it sounds like updating your refs with like fetch or rebasing so that you're on the latest commit of the branch that had the squash commit so that it has the updated information with the squash in there. Will do that, because I have seen a lot of times you open a PR and then all of a sudden you're like, I have like 30 commits that should not be there, and it's your branch wasn't updated when you were pushing. You hadn't fetched or pulled and gotten all of the latest information in, and I see that all the time. Yeah, it's a struggle.
Yeah. Okay. It's funny because I'm so glad that in a way that I don't have to deal with a lot of these, because I tend to work in small teams because I'm in DevRel. And so it's like either me committing my own thing, because so many things I'm like, oh my God, I would cause, granted, you can always.
A lot of my Git panic crying came from the fact that my first developer job, there were no code reviews. We didn't use GitHub. Like it wasn't any of that. And there's a whole social aspect to GitHub in and of itself. And people are just like, yeah, use GitHub. And you're like, they're like, opening a PR is not one step, okay? Like, it's not just like, oh, go open a PR. So I definitely have in that 11 blog series, like some stuff on working with the team and like a lot of the things that you'll encounter, because it was all new to me. And then I started crying about interactive rebasing.
So you mentioned that, I mean, I know most of this you did via the command line, but you mentioned that you prefer to use a GUI tool.
I use command line, and I use the VS Code buttons for things like git add and git commit, things that I'm doing every single day. But I cannot visualize. I have aphantasia. So for understanding what is happening with my branches, I will often have Git Kraken or Sublime Merge open so that I know what I'm looking at and what I'm trying to do, which was a lot of what I was trying to show with Git Kraken. But someone gave me the tip that you should say what you expect, which then kind of backfires if what you expected did not happen during a talk. So
yeah.
Yeah. So yeah, like you do not have to use command line to understand and use and be a pro at Git. It just seems like a lot of the people who have like stared into the Git void and the void stared back use command line. So that a lot of people assume that if you're going to be good, you have to use command line, which like not really.
Yeah. Let's see. Nick says he's pretty comfortable in the terminal for a bunch of stuff, but when I do a Git rebase, I leverage VS Code. I need to get more comfortable with interactive rebase. Or do you? Seems like interactive rebase, you could potentially get yourself into a lot of trouble.
Yeah, which is why I start with here's a way. You just keep a clean copy in the cloud, and then you mess up as much as you want. Because I think that's a lot of it. Like you're messing with stuff where it's like it's your work. You could lose your work, and that is what keeps a lot of people out of it. But like, there's always a clean copy somewhere.
Right. So you just keep working like
in local.
Don't push
until you like it. Yeah.
Exactly. That makes sense.
Yeah.
You know, I guess the whole point is you can always undo this stuff.
Yeah, and the abort command is super helpful. You can leave in the middle of a terrible merge or rebase and just start over after you've like had a break.
Yeah, I mean, I even use I do stuff like that even when I'm working locally, and I'm just like trying to build something, and I'm like, this, you know what? I did this all wrong. I need to start the whole thing over, and I don't want anybody seeing this big mess. So I'm just abort and wipe everything out and go back to where I started from. So, so you got some thanks from Sam and from other people in the audience. This was really, really great, really useful. I think, you know, it's one of those that I probably like bookmark it and come back, and when you have these troubles, kind of scan through and like see how you do it.
Yeah, and I think a lot of people aren't introduced to just like, what is squashing, right? Like we hit a button in GitHub, but what is it doing? And you know, maybe I'll be able to show it.
You did eventually.
I did, yeah. We squashed something. Don't worry about it.
Yeah.